Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. Hi everybody. So today we will continue our lecture on chapter 5, local area network. So you have heard about this, but today in this chapter we will discuss a little bit more detail about this topic. Okay. So in this chapter, we will discuss about 5.1 LAN technologies, LAN system, bridges, and also LAN design and analysis. Okay, first subtopic is LAN technology. So what is LAN? LAN, local area network. Local area network is a network which is in a single building or perhaps a campus area with multiple buildings. What is we call local area network or LAN. LAN doesn't have anything to do with the size. So a network of two computers is just as good LAN as having 2,000 computers, meaning whether it is only 2 computers or 2,000 computers, as long as it is in one area, it is called LAN. It can be called local area network. So another one is called WAN, WAN. If you would have a connection to an ISP, internet service provider, or perhaps a lease line to connect your headquarters network to a branch office, that's where we talk about WAN. This one we will talk later. Wide area network, WAN. So the background of LAN is first to interconnect distributed communities of computer-based DTEs. Okay, DTEs is computer data terminal equipment located within a single building. So this is the computer to interconnect distributed communities of computers located in single building or localized group of buildings. So LAN is considered as a private data network. So this is example of LAN connection. So you have many computers connected to hub, and also you have like a printer and also server. This is what is this? This is maybe a star connection. Okay, so this is one example of LAN connection. Okay, next is LAN architecture. So in this topic, we will discuss about the topologies of LAN architecture, the transmission medium, layout of LAN, and also medium access control. So LAN topology. So there are few types of topologies. We have discussed this before. First is bus. So bus, you have backbone, and then all the computer connected to that line. Okay. Second is tree. Okay, this is in this tree connection, you have a few line, and all this line connected to a head end. Third is ring. So ring, you have the computer is connected in form of a circle or ring. Okay, and for star connection, all the computer are connected to a hub. Okay, a hub. Central hub, switch or repeater. So all the computers are connected to one hub. So these are called star. Okay. So a bus connection. First is bus connection. This is the example of bus connection. Characterized by the use of a multi-point medium. Okay, you have multiple devices. All stations attached through hardware interfacing directly to a linear transmission medium or bus. So bus is a linear transmission medium. This is considered bus, backbone. Okay, full duplex operation between the station and tap. Full duplex, so meaning the flow of data is two direction. Full duplex operation between the station and the tap. This is the tap where the computer is connected to the bus. Okay, allows data to be transmitted onto the bus and received from the bus. So full duplex operation allow data to be transmitted onto and also received from the bus. At the end, at each end of the bus is a terminator. So this is the terminator, which absorbs any signal, removing it from the bus. So the function of terminator is to absorb and remove the signal or unwanted signal from the bus. So this is example of a transmission of data frame on bus LAN. Okay, so let's say this is the frame. C transmit frame address to A. So C, this computer or the person in using computer C want to transmit the data from C to A. Okay, C transmit frame from address from C to A. Frame is not addressed to B, so B ignore. When the frame arrive at B, but there is no the address, the header shows that the address is to A. So the B computer ignore the frame. When it arrive at A copies the frame and it goes by. So computer A copies the frame of the data from C, but the frame will continue going. Okay. For tree topology, the tree topology is a generalization of the bus topology. The transmission medium is a branching cable with no closed loops. Okay, so this is no closed loop, no. The tree layout begins at a point known as head end. So this is the head end. One or more cables start at the head end, and each of these may have branches. So you have one cable and then it go to the branches. In this case, we have 3 branches. Okay, branches. Again, a transmission from any station propagates throughout the medium and can be received by all other stations. Okay, so let's say you have this station. This is a duplex transmission. It can go from here to anywhere, the destination of the data. Okay. Ring. In the ring topology, the network consists of a set of repeaters joined by point-to-point link in a closed loop. So you have a repeater. So ring, the network is in closed loop, joined in a closed loop. Okay. The repeater is a simple device capable of receiving data on one link and transmitting them bit by bit on the other link as fast as they are received. So normally for ring topology, they have repeater and it is connected in a closed loop, joined by the point-to-point link in a closed loop. This is the example. Normally it could be this is like a circle. Okay. Even though it's seen as a square, it is considered as a closed loop. So that is a ring topology. So ring topology, each station attached to the network at a repeater. So for the bus, it is connected to tap, but in a ring topology, each computer attached to the network at a repeater and can transmit data onto the network through the repeater. So the repeater can be used to transmit data to the network. As with the bus entry, data are transmitted in frames. Okay, we have discussed the example, the transmission of the frame. Because multiple stations share the ring, medium access control MAC is needed to determine at what time each station may insert frame. So in ring topology, it involves MAC, medium access control, in order to determine the time each station can insert the data, the frame data. Okay, frame transmission in ring. C transmit frame address to A. Okay, so C want to transmit the frame to A. Okay, and the ring goes this way, anti-clockwise. At B, frame is not addressed to B, so B will ignore the frame from A. So when arrive at A, A copies the frame from C, and the frame goes, continue. When arrive at C, C absorb the returning frame. So this is the process of frame transmission in ring topology of LAN. So star topology, each station connects to central node. So in star, each station will connected to the hub. This is called central node. Okay, this node, this is central node, central hub or switch or repeater, the name. Each station is connected to this hub, usually via two point-to-point link. So there are two links. Either central node can broadcast physical star, logical bus. Only one station can transmit at a time. So at one time, only one station can transmit. Or central node can act as frame switch. Central node also can act as the switch for the frame. So that's the story of the topologies of LAN. We have star, bus, ring, and so on. Okay, and three. So we have four type of topology, and we have another one which is hybrid. So how do we choose the right topology for our system? It always we need to determine based on reliability, expandability, performance, and also needs to consider medium layout, wiring layout, and also access control. So these are the factors that need to be considered in order to choose which one the topology will be used in our LAN. Okay, so that's all for this first subtopic of chapter 5. We will meet again in next video. So thank you very much for your attention. Until we meet again, that's all. Okay, bye-bye.